Hello, everyone, and welcome back to Decision Analysis and Forecasting for Agricultural Development. Today, we're going to talk about participatory methods. I'm Cory Whitney. I'm very excited to deliver this particular portion of the content. I want to remind you that we have a Slack channel and we have a website dedicated to this, to all of this content. So please visit that website if you have not yet. That's hosted on Shiny Apps. So I'll lay out a basic foundation for these participatory methods, talk about the process by which we build a model, about effective participatory methods, which is a work in progress, which ultimately you will be taking forward after imparting some procedures and ideas here. The task will be ours to apply and approve these, and you'll be applying these in your own work and contributing to the advancement of these procedures. So I'll tell you about the basic principles, and I'll spell these out because I think this is important. When we're doing this, we try to, the first principle is that we incorporate all the important aspects into our models. We model systems using all sources of information, including local and expert knowledge. We'll talk about what expert means in a moment. We explicitly consider uncertainties about inputs, processes, and outputs. And that means we try to get from this confusing but comprehensive version of our understanding of an impact pathway to something that causally introduces us to the interactions and tells us how they work. We identify key uncertainties for measuring the value of information analysis, which we'll also talk about a bit later, and we update and clarify the model when new information becomes available. We build these models to examine alternatives, and we try to do that in an explicit and logical way. That's what we're looking for here. It's often valued on a single coherent scale, and that may vary. And there's sensitivity analyses, these value of information analyses, can tell us about changes that might influence decisions, but ultimately we're interested in how A, let's say that's an intervention to an agricultural system, influences B for, and let's say that's nutrition implications for a community, right? So any relationships here should be about how this intervention will affect that outcome. So how do we do this? Well, simply put, we convene experts, stakeholders, and decision makers to jointly develop a causal decision model. And we gather subject matter knowledge, as well as context and decision-specific information. So we try to learn everything we can from these experts. And experts here means those who know about the system. So it doesn't necessarily mean they have to be academics or otherwise have a high level of education. If they know about the system, then that's the expert we need for this process. We'll hear more about this soon from our other colleagues about this process and about convening and identifying these experts. So this is generally applied to development problems and development contexts. Often these have a lack of concrete data, many sources of information, and a wealth of expert and in-depth knowledge. Agricultural systems are a fantastic application for decision analysis approaches and for these participatory modeling approaches. We work with both experts and analysts. Experts, again, means those with knowledge about the system at hand. We iteratively frame the decision. That is, we try to understand what the intervention is, what's being proposed. We analyze that. That is, we go through a process of understanding how that works, and then we model it. We draw it up as a conceptual model together. I frame this as a four-part process, from specific to general and back to specific again. So first, in the problem definition, that is in the framing part, we define the problem, and then we start with divergence. That is to say, we collect ideas, where we open up a discussion and we gather diverse variables and interactions and unpack and disaggregate all that complexity. We try to understand holistically and comprehensively how the system functions. And then we start with a convergence phase, that is trying to clarify relationships and concepts, get from vague to specific. We have a focused discussion We develop concrete descriptions in the form of circles and arrows, and we peer review a graphical model. We have a big drawing that we can look at together. We then convert that to a programming language, that is, we program it into a model that we can run. We use that to identify important variables, and we follow up and share the results of that so that we can provide some kind of decision relevant input for those experts. So just as an example, here's we always do this in a workshop of some kind. Now in pandemic times, slightly different, but we always work together in a group. Here are experts and analysts working together to build a model and create forecasts for fruit tree effects for smallholder farmers in Kenya. And when we do that, you've seen this in the past, but when we work with groups, we could have this plenary space that is where one person talks and others listen. We can have the individual level where each person thinks on their own, and we can have working groups. And we try to take advantage of all of these possible spaces. So once we've defined the decision, we break it down into specific questions. So this particular intervention and the question as to whether this intervention and to what extent this intervention will affect the outcome is broken down into specific questions. We divide individuals among working groups to work on these individual questions. They consider that question on their own with a neighbor, share that with the whole working group, create a graphical representation of those ideas, and repeat that for every question. They rotate around. We'll look at this soon. They rotate around to the different questions and work on those together. We then create a final graphical model, which we can then use to begin the phase of programming. In doing this, we need to overcome cognitive biases. The one I'll talk about now is the fox and the hedgehog, and I'll use the work of our friend and colleague, Dr. Yiyun Xu at Australian National University. She spoke at our institute earlier this year. And Yiyun Xu is interested in how groups interact and what affects group work processes and how effective groups are. And one of the big factors is this thing which we can call the hedgehog and the fox, or the fox and the hedgehog. There's a 1953 essay by Isaiah Berlin that outlines this. If you're interested, I can share that as well. But it's basically about different cognitive styles. This was carved on a stone by Archilochus, and it says, the fox knows many things, but the hedgehog knows one big thing. And it is to say that there are different cognitive styles, as I said, different ways of thinking about things. If you're a fox, then you have lots of different options. You can eat the hedgehog, you can wait to eat it later, you can test conditions, watch the hedgehogs, make a plan, etc. You're comfortable with nuance, contradictions, and changing plans. And if you're a hedgehog, you just have one thought: don't get eaten. So this is interpreted as being the cognitive style where you live with the single organizing principle, single-minded and driven. And essentially, in doing our group work processes, we try to incorporate those different styles together without having one drown the other out. And it's often the case that hedgehogs are the ones who get invited to give talks and to speak on television, et cetera, because they're quite confident and they have really clear and precise things to say, whereas the hedgehog might be rather more nuanced, but still have useful inputs. So we want to try to get both of those on board, and we do this by using brainstorming, collective brainstorming processes. And I call this the 1-2 cafe. It's a structured conversational process where we disaggregate and discuss ideas. So we take those individuals, we divide them up among working groups, and those working groups will shift around and work on various different problems, not together. So these individuals will go separately to new problems, so that we get everybody's ideas and we get different groups of people working on these things together. And we try to get, again, from this comprehensive but confusing understanding to this comprehensive and clearer understanding of how these things interact. We use different facilitation techniques from the Liberating Structure collection. And basically we engage everyone. We try to do simultaneously, get everyone on board and work together to generate questions, ideas, and all suggestions are included. And the idea is that it unfolds and opens conversations and shifts different ideas and solutions in a rapid fashion. So what we basically want to do is, I'll tell you about the process that we've been using. So we take roughly 5 minutes, and each person individually who's sitting at this table will list their own ideas related to that particular aspect of the decision problem on their own. And then for another 5 minutes, they'll discuss this with their neighbor and look for surprises, create a new list together. And then for around 20 minutes, the whole group will discuss what happened on their individual level, in their smaller group level, and then they'll come up with, hopefully, first of all, quite comprehensive collection of ideas, which they can then hopefully convert into something a little bit more clear in the form of bubbles and arrows that we can work with. Once we've done this and we've collected all of those models together, then we can aggregate them. We can put them all together into one big model, and we program that. So here you can see our friend Carolyn Nakaketo helping us in Uganda. Here are just some of the ideas that were sketched out in those working groups, and we're programming it here into a Bayesian network in the Agena risk program. But we can also, that's what that looks like in the end. You don't need to see the details, but just to see that it is a complex model that we came up with. This one in particular for zinc and the effects of trees, particular trees being planted on zinc at the zinc gap, nutrient zinc gap at the household level. We can also program this, as you will be doing, as a Monte Carlo simulation using the decision support package, the decision support library in R. So I've laid out a basic foundation and told you some of the important principles. We talked about the process by which we build these models. We talked about some of the effective participatory methods. These are work in progress very much. And now it's time for us to take this forward together. So after imparting some of these procedures and ideas, the task will be ours to apply and improve these procedures. Just again, some resources for this approach. We wrote a working paper for eCRAF on these processes. We've published some open access code and scripts and data in RPubs, for example, and also the processes whereby that model was developed that you saw our friend Carolyn Nakaketo working on. That is also published in the Earth's Future article shown here. So that's just an advertisement for some of the resources that can help you follow through with these approaches, but look out for more from our colleagues coming soon. And I look forward to working on this and seeing how it is that you apply this in your projects.